Not going to be able to confirm answers. It's all on you guys. But I want to talk through it kind of like we did yesterday, and hopefully we get through all of them. So once you open it up and you start thinking about it, let me know what you think.
Remember, guys, team review. Work together.
Yeah. For number one, I got A.
Oh, yeah, sorry.
Take 30 and 35
Awesome.
Wait, guess what? I used my method on 2 equations, and those are the last one I needed.
Did it work?
And it worked. I was like a 94, I think, and I got 1 question right. Okay, so I got to a 98. Got 1 question wrong, we're back to 79. I was about it just quick.
Oh, that's the kind of thing that makes you want to throw it out the window.
So then I had to get back up, and then I was almost two away. And I was not trying to do all that math. We was already late, so I was like, I'm just leaving my method. I don't know understand questions too, so y'all got that.
Well, let's talk about question 2. This is the easiest complicated question you're ever going to see. I'm going to say that again. Number 2 is the easiest complicated question you are ever going to see. It tells you that circumference is 244 pi, right? And you want diameter. So which equation do I need to use? We need to do this one, right? You need to substitute it in. So if 244 pi is the circumference, 244 pi equals pi d. How do I get the d by itself? Divide by pi. What happens when I divide by pi? And so what's d? Voila. Easiest complicated question you're ever going to see. That's it. Notice that this is the first time it says semicircle. Yeah. No, you're all good. The 2 equations for circumference are c equals pi d and c equals 2 pi r. We know that c equals 244 pi. So if I substitute 244 pi in for c, and I'm looking for d, my equation is 244 pi equals pi d. You want to solve for d, divide by pi and divide by pi. They cancel out, and what are you left with? D equals? Boom. So the area formula, A equals pi r squared.
So the answer is 244?
Mm-hmm.
For 2?
Mm-hmm. Easiest complicated problem you're ever going to see. Semicircle is half a circle. So normally I would have shaded it in. I'm looking for the area of the purple. Absolutely, yep. So if 11.4 is the diameter, what's the radius?
It's 5.7.
And then you want to divide the whole thing by 2 because you want a semicircle. Semi means half.
What's the equation for area pi r?
So number 3 and number 4 look the same. It is the same picture. What's different? Mm-hmm. So in number 3, you're going to do area. And number 4, you're going to do circumference. You could. Mhm.
So it's pi times 11.
I love it when a plan comes together.
You put it in the area, A equals and then R squared, you do 2 and 4, 4, and then square
So what you guys do for question 4?
Question 4, I got three wrong.
You submitted?
Oh,
What do you mean you got question number 3 wrong?
you have to go to
I got 38 or 35.8 for number 4.
Yeah, I get them. What is the concept of the circle with the area? So, alright, area.
Because it's solving for R.
Okay, so now the
6 squared.
how do you get the area?
A squared.
Area,
Yeah.
unsquared. Okay. Unsquared. And then it becomes 2. Right?
Is there something to find with the side too?
So we don't know the page. Yes.
You want to start with your area, find R, so you want to divide by pi and take the square root. And once you have R, substitute that into circumference.
Okay, so like area one is this.
No.
And circumference is so we only have area here, so should we like put in that number? You can solve for R. So you can put R here. So you divide by 5. And then I divide this by 5. Yeah, and then you do divide that by 5, then you square root. This is and then that number you can plug in. I can help with number 6.
Mm-hmm. 6 is kind of hard to look at, but if you can draw it out or color it in, it helps out a little bit. So arc QT is my first question, right? So I'm going to highlight QT. What spotlight is shining on QT? So if I go from the small arc or the small angle to the big arc, what do I have to do?
5 times 2.
Mm-hmm. And then the other one is asking the measure of STR. So this angle shines onto what arc? So if I go from the big arc to the small angle, I'm going to divide by 2. So again, from the arc to the angle, you want to multiply by 2. And then from the angle to the arc, or the other way around, from the arc to the angle, you want to divide by 2. Small to big multiply, and then big to small divide. So S to the arc, I'm going to double. And 30 to the angle, I'm going to do half. If I go too fast or you want me to go back to something, I'm happy to go back, okay? I'll also post this video. My goal is to get all 26 done in class together. So arc BD is all the way from B past C to D. The 47 is right here. Mm-hmm.
47 plus 90, that's it.
Mm-hmm. Kaylani, Nee, Isaiah, how are you guys doing out there? Okay. Shout out if you want me to do one that we haven't done yet, or you want me to go back. Okay. What did you do with those 2 things?
Oh, I did 65 divided by 2, and then I got 32 on 5, right?
So when it is an angle on the edge, you can do that. When it's an angle in the middle like this, they're equal. So this angle here is 65 degrees because that's a central angle. What you need to notice here is what's RT?
A straight line, a diameter.
It is a diameter, which makes this a semicircle. How many degrees in half a circle? So what should these 2 things equal?
Maybe it's all right.
I mean, this is not.
It's going to be smaller than 95. So it's asking for X. If it was asking for the arc of RS, you would plug it back in. But because it's asking for X, you just solve.
It goes like that. So the time for you just times that by 2. Please, thank you.
Good explanation. Question number 9 goes back to an inscribed angle. So remember, central angles are equal. Inscribed angles, there's a big and a small. So angle BCD is that purple angle. And arc BAD is this arc. So how are the purple angle and the red arc related?
I don't know at all.
How are they related in number 6? What if we had the angle, what did we do to get the arc?
Oh, divide by 2.
If I start at the angle is small and we go to the big arc, we multiply by 2, right? So, yeah, Kaylani, you got it. Which one do we multiply by 2? The small thing or the big thing? the small things. We're going to take that small angle, 4x minus 50, and multiply it by 2, and then set it equal to the big arc, which is 105 plus 3x. You don't have to multiply that one. Because we go from the small arc to the big thing. 2s, two smalls make one big. You do have to. 2 times negative 50, absolutely. So 8x minus 100 equals 105 plus 3x. So then I subtract 3x from both sides and I get 5x. And I add 100 to both sides, right? So I see a minus 100, I add 100, so that's 225. So x equals 25. Am I done? Why not? So BAD is this one. We got to substitute it back in. Did I do it? Did I mess it up? Oh, yeah, I sure did. Yeah, don't listen to me. That's not 225, it's 205. So that's not 25, that's 21. 41. Oh, Lord, have mercy. I need to get my calculator out. So then we put 41 in here.
Which makes the
228.
Did that make sense? Do I need to go back?
You don't have to do it
Everybody got quiet thinking about question 10. So because I'm looking for the shaded sector, we got to do 180 minus 45 is 135. It's always the angle over 360. 360 always in the denominator, just like the hypotenuse in trig. Then area is pi r squared. If the r to p is the diameter, then the radius is 4. And then I heard somebody in classroom discussing that we've got pi in our answer choices. Props to Tatiana. So we don't have to put the pi in our calculator. We can just bring it down like we're solving an equation and not using it. So then 135 divided by 360 times 16 is going to be our answer here.
So 72. 6. You know, that's what I made.
It helps to confirm our guesses in the calculator.
the square organ.
Well, you know, that's question.
That's a hard level question. And question 11 is the easy level question. It's the exact same thing. It's just the easier version.
Do you still have the square? I'm sorry, you can answer those.
So this is just units squared. You do have to still put it in. So it's going to be your angle. So that's 130. Divided by 360, always 360 because circles have 360 degrees. We're talking about area. So yes, the question was, do we need to square it? So pi times the radius squared. And yes, you do.
Which makes the answer 48. I thought it was 6. See, I can do 12 on my own. I was really good.
Nine? Yeah. 228.
Angelina, so it's up here. The angle is half the size of the arc. So you need to multiply that angle by 2. Did you multiply it by 2? So remember, the angle is always half the size of the arc. You need to multiply the angle by 2 in order to make it equal the arc. And that'll help. I don't expect everybody to go at the same pace. So if you need me to go back, I'm happy to do that, okay? Question number 12 is the same as the last two with 2 differences. So we're asking for length now. So instead of using area, we're going to use circumference. And instead of giving you the radius, I give you C. So remember, it's the angle over 360 times C. So can I just substitute that whole thing in? You don't even have to find R. You can find R and then put it back in, and hopefully you'll confirm that it's still 216 pi. But remember, this formula is just the circumference in the area. Normally they give you the radius or the diameter, so you have to do something to it. But if they just give you circumference, that's a gift. 120 divided by 360, and then multiply by that 216 pi. What do you notice about your answer choices?
We can take out pi.
We can take out the pi. So work smart, not hard. Fundamentally, I'm kind of a lazy human.
How did you get
72? 120 divided by 360 times 216. And then you put the pi next to it. Okay. What do we do with chords? It's up above Wesley's head, if you've forgotten.
Oh, what do we do with missing the X?
So it says, what is the measure of RB? RB is what I'm looking for. That's that missing thing.
So it would be 2 times, or 2, or just 2x.
The way you do it, Dalton, is you usually multiply the 2 things that are on the line that are numbers, right? So you would start with a 3 times 15 and then divide by 2. Yep. It's a lot to remember here. I think it's finally starting to come together, though, and it's come together a lot faster than usual.
Things there. Like the keys, so we get formulas, so I remember them.
Wait, so we actually birthday pay? Oh.
And if you were, I would have to erase the board. Mm-hmm.
I think of it like this.
The SOLs are usually done in the...
What if I got like a tattoo of all of those, like right here? And just like a fake tattoo?
That's gonna be cheating. You put your arm around me. I feel like this. Like, hey. Yes.
Well, can we just cut it now?
Just imagine that just like.
As long as there have been tests, there have been students trying to cheat the test. Just saying. I know for sure when I taught 7th grade math that one of my students cheated on the 7th grade SOL and ended up in 8th grade algebra because he came back to me about 3 or 4 weeks into algebra and was like, Ms. Doherty, I don't know why I cheated on that test. Can you please put me back in math 8? I do not want to be in algebra. Dude, you cheated. That's where you got. How did I know he cheated? Because I have intuition like that.
How do you cheat? Do you like treat
I know how he cheated too, and I asked him about it. He was like, "Yep, that's how I did it." I was like, "Okay, well." Choices and consequences, man. Choices and consequences. I'm not gonna tell you it's not that good.
And he had it on, and he was like, "Do I need to take it off?" They're like, "No, you're good." He was decision like this. And he had his phone on too. He legit asked him, "Do I need to take it off?" They're like, "No, you're good."
Some proctors are.
He's sitting right next to me.
I remember this one girl, she was on a test, and like, well, with her friend, he had the same kind of answers, and we got the same kind of wrong. And like, the principal did everything. Where's my class? It was mine and heaven. Yeah, I remember his class. It was 6th grade, like, it was 6th grade.
I remember I had science class
Guys, I'm not trying to tell you what to do, but I'd really like to get this done before we leave today.
The first question was, "Can you really see me?" Then you took away half the thing that made it easy.
What are you talking about? They're all mixed up. Okay, so when you have two intersecting chords, you got to multiply x times 5, and then you got to distribute 2 times 3x minus 2. So when you distribute, you get that 6x minus 4. What's x equal?
-4. Right?
Does x equal -4 or +4? Are you sure? What's x equal? How do you solve it?
Wait, because it would be -x equals -4. So
x equals 4. So why isn't 4 my answer choice? KZ is all the way across that red line. So I've got that little piece that's 2, and then 3x minus 2. So I got to put a 4 in here.
that should be 2 times.
X equals 4, you plug it in, and then you get 12.
Alright.
Yep.
I'm hoping the same room as you. I'm definitely shooting.
Is it actually 12? I was just guessing.
Why would you do that?
2 plus 12 minus 2 is 12.
Oh, God.
Question 15 is 14.
I see you choosing my method. I know, 14.
I just.
Hmm?
Yes, the rest of it.
14.
Why is 14 10?
Because 3x or 3 times 4 is 12 by 2.
And that gives you from L to Z.
You gotta put the extra 2 from K to L.
Evil, right? From K to Z, you got to add in that extra 2.
So you already did 15, 16.
Oh, yeah, for our point.
So we need length, so that's circumference. So 166 divided by 360 times pi. The radius is 10. So pi times 20, or 2 pi r. Is that correct? Yeah. Not 2 pi r squared, 2 pi r. Yep.
So would it be 28.97?
Or
Mm.
16.6.
I don't know. Which one is it? Discuss.
I guess. So my answer is.
We got 289.79 or 0.72. So like if the decimal is in this place for.
Jaden says A.
I say A too.
Tatiana says A. Anybody out in Zoom have a vote for question 15?
Yeah, look at that.
28. All right. Sweet. All right. 16, you got an outside piece and an inside piece. So remember, you got to do the outside times the total. And the outside times the total. Okay, so we got to do 6 times 6 plus x.
Oh, it's not. Yeah, I got you.
I would add them first and then multiply, but it doesn't matter. Honestly, you can put the whole thing in the calculator exactly the way you see it and do it in one step.
I got them mixed up. There we go.
We can do it that way. 25 plus 72.
Should be 61.
I got 49. Oh, maybe I did something crazy though.
I got 8.2. What? How did I know? No, you got 3.6. Oh yeah, I had 8.16.
It should be.
So 8.2. And divided by.
Mm-hmm.
Wait, so we're subtracting my 36, right?
Mm-hmm.
Yes, sir.
Plus, I got 8.72. Minus 36. I got 61.
What you doing, bro?
Oh, I forgot. 76,
I don't have that number.
Plus, okay.
Because 5 times 12 is 60, not 72.
Oh. Oh, I got it.
Yeah, same. I don't know how to do it.
Okay, there we go.
17 is exactly the same as the other one. It's the outside times the total. It just so happens that they're the same thing.
Oh, they're both X's?
Mm-hmm. And then the outside times the total. So 6 times 6 plus 9.
So 2X.
So x times x is x squared.
Oh.
X times x is x squared. And then you can put this whole thing in the calculator exactly the way you see it. 6 parentheses 6 plus 9. Close parentheses and you get 90. And then take the square root, 99. So 9 plus 6 is 15, and 15 times 6 is 90.
So 90, square root of 90 is. Oh.
So just remember when you multiply 2 x's together, you get x squared.
It's 9.5. I have 5. Oh, wait, what? How do you 45? Because I times it's x squared. Not 2x.
X plus x is 2x. X times x is x squared.
Yeah. That's when I get scared.
Yeah.
That's all
I don't-
I always have to go.
What about 18?
If you keep getting the same answer over and over again, you're like, all right, something's not right, so you go back and change it.
I never really changed my answers. I still don't to this day. Like I make my decision and I go with it. I don't ever second guess myself.
They were on S1, they got like D, they're like, all right, if this one's D, no, I'll switch to A.
Don't do it.
That's what I do.
Don't do it. Commit to yourself. Have faith in yourself.
Because sometimes I commit, but I just I'm guessing.
probably not actually powerful.
Sometimes I might always go back over it.
Yeah.
Yeah.
I just pretty big problem.
What do I do with these two things?
Same thing you did last
Same
time,
thing.
except for
Same thing. That's what they're saying. That's what they're saying.
Outside times the total equals outside times the total. Here we've got things on the outside and on the inside. We've got things on the outside and on the inside. In this problem, we only have stuff on the outside.
So what do we do?
They equal to each other. So this is like the ice cream cone ones. These are just tangents. They meet at right angles. So they meet the circle at right angles. You probably won't need to know that, hopefully. But they are congruent to each other. So you just set this up. 9x minus 7 equals 29.
It's 4.
It's 4. I love it when it's easy. So number 19 is similar to number 18, but it's going to ask you what the perimeter is.
Oh.
And nothing's labeled. You're going to have to draw this. Okay, so if AE is 4, what else is 4? What other segment intersects at A? AD. So both of those are 4. Then I've got EC, which is 5. If EC is 5, then what other segment meets C?
BD.
F, C? So if EC is 5, FC is 5. These two are tangents with the same angle. These two are tangents with the same angle. So then I come over here and BF, Gage is already ahead of us. BF is 6. That means BD is 6. And if I want the perimeter, I got to go all the way around. So 6 plus 4.
Wait, that's 6? 4 plus 4 plus 5 plus 5 plus 6 plus 6
Mm-hmm.
is 30. Great job. Oh my god, we only have.
We only have 6 more problems. What do you think about question 20?
I think it's great. From A to B, and the diameter is 2.5. So you just do pi times 3.5.
See, that's not weird, but is everyone like maybe stretching your back or something really hard? Like, you might do it more, but like, it starts hurting. Just me. Like, I was just stretching it, it's not hurting, but like, I still like to stretch.
Oh, it's arc math.
My back hurts.
So we do, it's divided into 1, 2, 3, 4, 5. So you do 5, 360 divided by 5, and you get that little angle. What's the angle? 360 divided by 5. 72 divided by 360 times. Yeah, that's what it is.
Yours been jammed, so it's not.
No, I never be jammed.
Is it
Do you have jam in your life?
Never mind.
He's probably already like helpless.
You have a James in one of your classes? No. He's alright, don't get me wrong,
He's
he's
a smart
smart,
guy.
but he is extremely smart. But I feel, I'm not gonna assume stuff, but
He
I can tell. I can tell, like, he studies, like, I mean, he's not bad at studying, but I mean, that's all he does. So,
I
Michelle
all
even
he
asked
does
me,
is study.
because we were doing the first thing of like Renaissance,
Mhm.
we didn't know what we were talking about. She was teaching us.
Nobody knew.
And he's, oh yeah, so in 1964,
And like the teacher didn't even know one of the questions, and he started like telling her about it.
she's like, well, I'll have to research that.
Maybe history is his thing. He just knows a ton about
He's
history.
probably one of those war buffs, like love World War II.
Mm-hmm.
Like, oh my God, don't get it. What's that one that did presents?
That's enough.
What is, it's missing something. What's it missing? The radius. What is the radius? If the diameter is 3.5, what's the radius? Thank you, Kaylani.
Lombardi.
I was 60.
The other way to do this is to find the whole circumference using pi d and then divide it into 5 sections. So you could do pi times 3.5 divided by 5. So you find the whole circle. and then divide it into 5 pieces instead of finding 1/5 of 360 and then multiplying. Doesn't matter which way you do it. Both this one and this one are going to be the exact same thing. How do I start this one? So imagine yourself at like ODU Stadium or whatever RFK Stadium is now that used to be RFK, right? You're at some kind of stadium. You're at like a Roman Coliseum somewhere. You know that 150,000 people can fit in here. What you're looking for is what piece is this shaded part. That's what I would do. I would go 1, 2, 3, 4, 5, and I go 1, 2, 3, 4, 5, and I'd make a line. And I'd go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and I'd make a line. And 1, 2, 3, 4, 5, and I'd make a line. So ultimately, you're going to see that you can slice this into how many sections?
That's like terrible. Are you make one of them as well?
It's 8 sections. So if the whole thing seats this and I'm doing 1/8 of it.
150,000 divided by
1,000.
divided by
It's 18,750, so it should be 8,000. 18,000. 1,000.
Okay.
Bro, because there's no commas on this. It was like excuses.
What about question 22? So I'm creating a flower bed around the corner of my house. And I want to know how many 1-foot pavers I need to buy. How do I start question 22?
Somebody go back to my orphanage.
Chill out.
I was at West Canterbury. I was going on.
No, he's got adopted.
Do we have any idea?
No, he's not.
I mean, the radius is 10.
Radius is 10. That's a great place to start. What else do we know?
I got 63.
What?
I got 63.
How'd you get 63? Okay, so we do pi times 20. That's pi d equals circumference. So that's 63. So the whole circumference is 63. Do I need the pavers to go through my house?
No.
No, ma'am.
So if I don't need these ones over here, I just need these ones. What do I do with that whole circumference? What part of the circumference do I need?
Divided by 10.
Why divide it by 10?
Oh, maybe not. I don't know. I'm just guessing.
You need to divide it by 3/4, right?
We need to divide it into 3/4, right?
5.75.
So if I divide it into quarters and then I multiply by the 3 pieces that I need,
0.75.
we can multiply by 3/4.
I just use the quarter method. You know, it's like
Okay.
5 cents.
You can absolutely, so if we do 63 and we divide it by 4 and then we multiply by 3, isn't that the same thing?
Sure. I just got that counted.
We just switched the 1 and the 4.
Oh, and then you do.
I got 47.25.
Okay, can I buy 0.25 bricks?
Okay, but think about it like this. You know, you said, do you want the path or do you want to go through your house?
Mhm.
That would be pretty cool though. Just imagine that we can have like your outside garden and you can have like your inside garden. That would be pretty sweet.
Ooh, what if you did like one of those glass bubble things?
Oh, that's so cool. I want to have one of those.
You're like,
Do that. Yeah.
Or like
oh,
it
that's
goes up,
But,
Yeah.
back down,
but termites.
and then you do like 10.
Okay.
That was funny.
48.
What's 63 times 3 divided by 4?
Yeah, I guess. So what did y'all get?
48.
We got 97.6.
That's not answer.
That's what we got. Yeah, but that's the closest to 48.
What? 63 was the closest.
No.
So if the whole circumference is 63 and I want 1, 2, 3/4 of it, 63 times 3/4 is going to be my answer.
Oh yeah, when you flipped it. Yeah, I was confused too. How can you do it? Oh, you use the butterfly method.
Community property multiplication works every time. This one's tough. This one you kind of have to back into. Kind of, yeah. So I know this is the arc length. That's what it equals at the end, 21.5, right? That's my like piece here in inches. And that equals, we did arc length, so that's circumference, times the angle, which is what I'm looking for, over 360, right? And we know the diameter is 15. So what can I change that C to? 15 pi, right? Because that C equals pi d. And we know the diameter is 15. Instead of trying to solve this equation, which you could do, why don't you just substitute in what you've got here? You know one of these answers is correct. So in the calculator, do 82 divided by 360 times 15 pi. And then 164 divided by 360 times 15 pi and see which one meets your target. So you substitute in your answers one at a time, divided by 360, then times 15 pi.
So we don't.
And then see which one matches. Sometimes it's easier to write the equation and then substitute your answers in to test to see which one is correct versus solve. You can absolutely do 21.5 divided by 15 pi times 360 in order to get the x. Okay?
I agree.
I disagree just because.
That is what he said, Brooke. Yep. How about 24? What are our thoughts on 24?
You check your area. 90 plus 3x plus 2x. Yeah. Plus 45.
How do you know it's 90? Okay.
And then you equal the 360 to solve for x.
Awesome. So I'm going to take my 4 sections, 90, 3x, 2x, and 45, and set them equal to 360 degrees, because all 3 pieces should add up to 360. Combine your like terms. So what's x equal? 45? Okay. Now, how do I find the area of the shaded sector? 45 divided by 360. Is that x or is that my angle?
Oh, x. So you get 45 times 2, which is 90. And then you do 90 divided by 360 times it.
Good golly, I already know the answers.
Estimate. Use your method.
Well, for this one, I know it's definitely not going to be 12.56.
Okay.
I also know it's not going to be 75.36.
And we also know it's not 50.24, so it's whatever other G hits.
And there, exactly. That's what
Okay,
I'm going
let's
to get
check
to.
it.
Yes, exactly.
May I check
I
it?
agree.
That's a 90 degrees.
Wait, I'm gonna.
What's that? X to the 8.
Squared.
And then that's the 5.
Pi? Are you joking me?
Yeah, I'm gonna put 26. Oh, and then you round up the 5 to 27. Oh, wait. But that was
I got 50.
yeah. Wait, I get 50.26.
Yeah, it's 50. This thing is closest to the area, so that's
Remember, anytime you use pi, sometimes they'll use pi button and sometimes they'll use 3.14, so your decimals might not match. Okay.
Oh yeah, the decimals match up when you do 3.14.
25 is a little hard to look at, but what's the one piece of information that you have there? If you get a question that is hard to look at, just focus on the one piece of information that you have. If you know this angle is 42, what else do you know?
X is 42?
no.
Oh, I thought that was like the coordinate line.
You multiply it by 2 in order to go get that. Absolutely. So 42 times 2 is 84.
And you divide that by 2 to come inside. Which is
Do you see any diameters?
F to B.
F to B is a diameter, and E to A is a diameter. How do those help?
So that means they're they're equal.
These are vertical.
Yeah, so once you do 84 divided by 2, that equals that. Oh, it's just 84.
Yeah, because the arc is equal to 42. For the middle, she was right.
I was right, because it's vertical angles. That's what I was saying.
No.
No, after it was wrong.
You are.
You didn't say anything about it.
Yes, I did. I said X is 42.
Okay.
It's not that one. You just look at the vertical.
Good golly, Karen.
Last question. How do I find the perimeter?
Add everything up.
Add what up? 6, 15, and 20? Why is it 82? Did I? Oh, darn. I was hopeful. We'll go back to it. So if those two are 20, these two are 15, these two are 6, you just add 6 plus 6 plus 20 plus 20 plus 15 plus 15, or 6 plus 15 plus 20 times 2.
6 plus 15 times
40, 30, and 12.
20
So I've been told I got excited and I skipped one. 25. I don't think I missed anything. 24. 25. I don't know. You had a little moment.
Wait, no, 25 is wrong. It's not 42.
It's not 42.
It's 84.
Why is it 84, not 42?
Oh, because they go like vertical. So this way you can see.
So the red doubles to get to the arc, but then these two arcs are vertical to each other. They're exactly the same. Okay. All right, ladies and gentlemen, that concludes our official class. I will